Hello everyone, and welcome back to this POTD streak of day 120, 34. So, if you are new to this channel, please like, share, and subscribe so that we can learn, maintain, and grow our streak together, right? So, let us quickly look at the question, what the today's question is about. The today's question name is a word explosion, and the tags given here as graph and disjoint set. If you open the question, it will be a hard category question. So, first of all, I would like to tell you कि अगर आपने like if you have studied this disjoint set, then this question is extremely simple for you guys. But if you have not studied it, then I recommend you that at least go and visit an article on a GFG maybe on to see how the find and union operations work on a disjoint sets. What are the optimizations there for find and union, and then it will be like very easy for you to understand it, as well as you can even solve it by yourself. So it's just the name there, hard question. It's like a very easy question if you know the disjoint data set structure, right? Let us look at this question and then let's start from the scratch for all the users here. So geek, तो ये बहुत बड़ा क्वेश्चन है यार, इतनी सारी इंग्लिश लिख रखी है. So the overall summary is that you have been given a mix array. I hope if you're watching this video, you must have read this question. So let's not waste the time to read this question again. So the overall summary of this question is that you have been given this mix array and danger array, right? So 1 and 2 is nothing but the solution's name. So there is one solution name as 1, there is a solution name as 2. Similarly, there are 5 solutions given here because n equals to 5. You need to mix these solutions, but there is one constraint. There is one another array also, which is danger. If you mix the solution named number as 1 and 3, then the solution will explode, right? So I hope now you have a clear understanding of what is mix and what is danger here. Let us read the constraint, what the question wants. So the question wants is that also from its past, it has been that the mixing solutions leads to an explosion and thereby completely ruining the experiment. So explosive solutions are mentioned in m cross 2 array. Okay. So help the geek to returning an array answer of size and where answer of I is equals to yes if it is safe to mix and no if it is not safe to mix, right? That's the only thing you need to find. You have to just tell that if you can mix the solution 1 and 2. If yes, then you need to say yes, and if it's not possible, then you need to say no, right? Let us see how. Let me tell you that how the input and output are coming. And then we will see that how can we code it, right? Okay, so we have this thing. This is the danger solution. You cannot mix 1 and 3 and 4 and 2, else it will explode and will ruin an experiment, right? So first of all, we just need to mix 1 and 2. Can we mix it? Yes, we can mix it because there is no violations here. It's just 1 and 2 here. यहाँ पे कोई भी नहीं हो रहा यार कि 1 या 3 1 को 3 से मिक्स करे या फिर 4 को 2 से, right? तब explosion होता है. So 1 and 2 we can simply say that yes, we can mix the solution, right? So I will say here that yes, I can mix it. Now the second thing came. Now the second solutions came, that is 2 and 3, right? So if you mix 2 and 3 and you have already mixed 1 and 2, then the resultant will say that you have mixed 1, 2 and 3, right? And you can see that 1 and 3 are coming in one solution, so it will explode, right? So for 2 and 3 you will say that no, I cannot mix it, otherwise explosion will be there, right? Let's go to the third. You need to mix 4 and 5, right? So you have already mixed 1 and 2 and you need to mix 4 and 5. So you are not violation any danger conditions here. You are not mixing 1 to 3 or 4 to 2. You're just making 4 to 5, right? So there will be no explosion and you can say that yes, it is possible. Now you have to mix 3 and 5, right? And previously you mixed 4 and 5. So if you mix 3 and 5, you will be mixing 3, 4 and 5. But again, you can see your overall solution will be 1 is mixed to 2 and then 3, 4, 5. And again, you can see 1 is not mixed to 3 in any of these two cases, as well as 4 is not mixed to 2 in any of these cases, right? So 3 to 5 is also possible. Now let's come to 2 and 4. This is our solution from our previous stage. So 2 to 4. If you mix 2 to 4, that means that you are doing 1 to 2 to 4, and 4 itself has the 3 and 5 in it, right? 4 itself. So what are you doing? What you'll be mixing 1 and 3. This entire solution is being mixed now. If you do this thing, the last part. So 1 is also get in touch with 3 and 2 is also getting in touch to 4, right? So there will be explosion. So you cannot do it. So you will say no. I hope you are getting the logic. अब मैंने जो ड्राई रन दिखाया यार, ठीक है, या सेम ड्राई रन मैं इसको कैसे यूज कर सकता हूँ अपने सोल्यूशन में. मैं यहाँ पे क्या चेक कर रहा हूँ. इस पॉइंट पर आओ, इस पॉइंट से आप देखने की कोशिश करो। जब मैं 2 को 4 से चेक किया तो मैं देखा यार कि मेरे पास प्रीवियस सोल्यूशन ये थे 1 से 2 3 4 5, राइट। और अगर मैं मिक्स कर देता, राइट, तो सबसे पहले 1 से 2 में 4 कनेक्ट हो जाता और 4 जो है वो इटसेल्फ 3 एंड 5 से कनेक्टेड, तो वो भी कनेक्ट हो जाता। सो दैट मीन्स कि हमें एक ऐसा स्ट्रक्चर चाहिए, हमें एक ऐसा स्ट्रक्चर चाहिए जहाँ पे जो भी सॉल्यूशंस मिक्स हो रहे हैं, मिक्स्ड सॉल्यूशंस का स्ट्रक्चर चाहिए सबसे पहले तो, मिक्स सॉल्यूशंस। तो हम इंस्टेड ऑफ ट्रैवर्सिंग ईच एंड एवरी एलिमेंट टू सी दैट कि अगर 4 ऐड किया या फिर अगर 3 ऐड किया, राइट, तो हमें चेक करना पड़ेगा इसमें कि अगर 1 प्रेजेंट है then we can say that 1 and 3 will be getting in touch and explosion will happen, right? So instead of doing that linear traversal and checking each and every time, अगर हमारे पास कोई ऐसा अपॉर्चुनिटी, ऐसा प्रिविलेज होता कि ये एक ग्रुप है, लाइक ये एक सेट है और इसका कोई रिप्रेजेंटेटिव होता, राइट, एंड इफ आई कुड हैव जस्ट चेक लेट्स से फंक्शन ऑफ 1, ये लेट्स से रिप्रेजेंटेटिव इसका इन्हीं में से कोई एलिमेंट होगा, लेट्स से 1, राइट, तो फंक्शन ऑफ 1 विल बी 1, राइट। तो उसके बाद अगर हम चेक कर लें कि फंक्शन ऑफ 3 में मिक्स कर रहा था, राइट, अगर फंक्शन ऑफ 3 इज नॉट इक्वल्स टू 1, है ना, क्योंकि 3 जो है वो इसका पार्ट नहीं है, तो डेफिनेटली विल बी नॉट इक्वल्स टू 1, तो मैं डायरेक्टली कह सकता था कि यू कैन नॉट मिक्स इट, है ना। अगर ये इक्वल आ जाता, फंक्शन ऑफ 3 इज आल्सो पॉइंटिंग टू 1, देन आई कैन से दैट तुम्हारा एक्सप्लोजन हो जाएगा, तुम 1 और 3 को मिक्स कर रहे हो। सो आई होप यू आर गेटिंग एन इंट्यूशन दैट दिस स्ट्रक्चर, इस स्ट्रक्चर को यूज करना पड़ेगा, एंड दिस स्ट्रक्चर इज नथिंग बट द सेगमेंटरी स्ट्रक्चर, सॉरी नॉट सेगमेंटरी पिछले पीरियड में सेगमेंटरी इस्तेमाल हुआ था यार, तो मैं वहाँ का बोल दिया। तो दिस स्ट्रक्चर इज नथिंग बट द डिसजॉइंट सेट, राइट, ठीक है, ठीक है यार। ओके, तो ये क्वेश्चन तो लंबा होने वाला है यार, बने रहो, वी विल सी दैट व्हाट आर हाउ वी कैन डू दिस, राइट। तो यार मेरे को तुम्हें पढ़ाना पड़ेगा, लाइक आई नीड टू टेल you or teach you that how the disjoint set works, then only we can do this solution, right? So let me use this part of the paint to write the things here and then I'll explain you one by one, right? तो ठीक है यार, शुरू करते हैं डिसजॉइंट सेट के लेक्चर को सबसे पहले, ठीक है। तो तुरंत समझते हैं विद इन 5 to 10 मिनट्स कि ये होता क्या है। सो लेट्स से यू हैव दिस पॉइंट्स एज 0 1 2 3 4, राइट, एंड इनिशियली ये जो 5 पॉइंट है यार इंडिविजुअली प्रेजेंट, नन ऑफ द पॉइंट्स आर कनेक्टेड टू एनी ऑफ इट्स, राइट। सो मैं एक पेरेंट एरे बनाऊंगा, right, which has the indexes as 0 1 2 3 and 4. So since it has not connected to any other, the parent of each node will be itself, so it will be 0 1 2 3 and 4, right. Now I am saying to connect the nodes I am using a keyword union, and I am saying that connect 0 and 2. So what it will do is 0 and 2 will be present in one set, right, and rest of the things will be present in their individual sets in the previous stage. But now since I have done union of 0 to 2, then this implies that find operation is nothing but it represents a representative for a particular such set, right. So it will be f of 0 will be equals to f of 2 since I have done union of 0 to, right. So हमारा parent array कुछ इस तरह से बदल जाएगा, right. So let's say we have chosen a representative among itself only, right. So let's say we have chosen it as 0. So now the parent array will look like 0 1 2 3 4. So 0 and 2 will have the same representative, that is 0 and 0 we appointed, right, and 1 will have 1, 3 will have 3, 4 will have 4 because it is not connected to any of the nodes, right. Let us do the second operation, and now I am connecting union 2 and 4. So now 0 2 and 4 will be in one set, because since 2 is connected to 4, as if a Facebook friend, you can say, since 2 is a friend of 4 and 0 is friend of 2, then 0 to 4 will all be friends, right. Okay, so 0 to 4 will be there, and then again this is 1, right. So 1 will be left outside and 3 will be left outside, and now I can say that f of 0 will be equals to f of 2 and will be equals to f of 4, and let's say 0, or we can also make an imaginative tree as well. So let's say 0 is there and 2 is there. So for this case now I will say that 0 is there, 2 is there, and this is 4 is there, right. Okay, so now the third step. तो अगर आपने यार कभी भी डिसजॉइंट सेट कभी भी नहीं पढ़ा है तो ये समझने में थोड़ी सी प्रॉब्लम हो सकती है, बट आई हाईली रिकमेंड यू दैट आफ्टर वाचिंग दिस लेक्चर please also read an article on GFG or whatsoever on the web, and you will definitely get a good understanding. So let's say union of 1 and 3, and it will say that 0 to 4 will be in one group and 1 and 3 will be one group, and now I can say that f of 0 is equals to f of 2 is equals to f of 4. Let's say it's pointing to 0, and now f of 1 will be also equals to f of 3. So now our array will look like, and let's say point it as 1, so it will look like 0 1 2 3 4. So 0 to 4 will have the same parent, or let's say representative, as 0 0 0 1 and 3 will have 1 and 1, right? So it will look like this thing. Yes, like this. So this will be my structure of my disjoint set, or you can see a virtual tree representation as well, right? Let us get to the implementation part now. So for the parent thing, I have to first make a parent of n size, right? And then let me write the pseudocode and then I will explain you. Or should I write it in front of you as well? Let us write here. So I will say that void, I will make a void initialize function, to initialize the parent. So initially what I did, for each and every node, the parent was the node itself, right? So I will say for I equals to 0 to I less than n, I plus plus. So remember this code, understand this code by your heartedly, because you will use the same pseudocode in our code, right? In our this question. So I will say that parent of I is nothing but equals to I, right? Let us build the find operation. So if you have to find of x, what you will do is, if parent of x is equals to x, that means that you have already find it, right? You have already found the representative of that set. If not, if you have find it, then you will say return x. If not, you will just recur back to the upside direction in the tree, right? What I'm saying is that this was 0, this was 1, 0 was connected to 2, and 2 was connected to 4. You can say like this also, right? So let's say I have called for f of 4, right? So it will say that f of 4 has the parent 2, right? So it will call for 2, it will call for f of 2. F of 2 will have the parent as 0, right? So it will call for f of 0, and f of 0 have the parent itself, because there is no other thing. So f of 0 will be 0. So that's what is here. If the parent of 0, if the parent of the founded x you are founding, if it is the same, then you have reached your base condition. So in that case you need to return 0. So in this 0 to 4, the representative of this set is 0, right? We have maintained the code that way. Or else the recursion I just showed you, for that you can write return find of parent of x, right? Because f of 4 was 2, and 2 was nothing but parent of 4. So we recur for each and every parent until the parent and the node itself get equal. So that goes our code of find. Now let us write the code for union as well. So let us say int x and int y. So union is nothing but, as I showed you in the dry run, that you are attaching 0 into one set. So how you can do that? How you can build that imaginary tree I showed you? So let's say you have a representative of x rep. For the int x you pass is x rep, right? And how you can find the representative? Using the find function, that is find x, right? Similarly, you find the y representative for which thing? For the y node I pass, and how you can find the representative? Using the find function, right? So now if the representatives are same, that is, suppose this is my structure, 0 2 and 4 is already combined, right? And again I call the union operation of 0 and 4. So you can see that the 0 has the representative itself as 0. You will run the find function and you will see that f of 0 is pointing to 0, f of 4 is also pointing to 0. So this case will be there, that if the representatives are already the same, then you don't have to do anything, because they are already in one set. So I will say just return. Else, if that's not the case, then what I will do, that I will appoint the parent of x rep is equals to y rep, right? You can do anything, y rep or x rep or x rep or y rep, that will remain unchanged, right? So great. So this is the very naive approach. Very we have not considered any path compression, any optimization while writing this while implementing this find and union code. So this is the very naive one. I hope you are able to understand it, right? So once we will use this naive disjoint set approach for find and union, and then we will see that if there any optimization in this is possible or not, right? So this is completely, guys, on the disjoint set, right? तो मैं ये क्वेश्चन नहीं एक्सप्लेन कर रहा हूँ जबकि मैं आपको डिजाइन सेट पढ़ा रहा हूँ, ठीक है? So now let us implement these functions in our code, and then we will see that how our thing is working, right? So let me write that find and union function I just explained you, so that you and I get in touch that how I'm writing the code, and then we will see our main logic, right? So let me write that code, and meanwhile you also try to complete the pseudocode which I just showed you in your code editor. So here goes the skeleton code, guys. The union function I just explained you, the find function I explained you, as well as the why we need to make a parent array, and we have initialized the parent from n plus 1 because the nodes are starting from 1 to n. It's a 1 based indexing, so I have to take n plus 1. Initially, each and every node has the parent itself. तो मैंने वही किया for I equals to 0 to I less than n, the parent of I is equals to I. Now the main logic comes. Let us see how we can do this question by this disjoint set, right? So let me tell you, let me explain you in this way. So let's say we have this mixture here, and we will have two solution name from there. Let's say A and B. You have to combine, and there will be some danger solutions as well, numbered as, let's say, C and D, right? Right. So I have to see that if I combine A and B, the explosion will happen or not. So what I need to check that if representative mixture that is to be mixed, अगर ये equals to हो जाए representative of mixture of danger one, right? अगर दोनों representative same है for A, B and C, D, that means that we will make a set where A, B and C, D will be a part, right? And you can clearly see that C, D will explode this mixture, right? तो मुझे क्या चेक करना पड़ेगा यार, मुझे ये चेक करना पड़ेगा कि राइट नाउ दिस ए हैज नॉट बीन मिक्स्ड विद बी एंड दिस सी एंड डी हैज बीन मिक्स्ड, राइट? अगर ये आता है सी एंड डी अगर मिक्स है तभी हमारा एक्सप्लोजन होगा. सो आई नीड टू चेक दैट इफ ए एफ ऑफ ए मैं इफ इक्वल्स टू एफ ऑफ सी, राइट? अगर इसका ए का रिप्रेजेंटेटिव सी का रिप्रेजेंटेटिव सेम हो जाए, राइट? अब हमें डी भी चाहिए है ना, तो हम बी को मिक्स कर रहे हैं ए में, तो हमें ये भी चेक करना होगा साथ ही साथ कि लेट्स से बी जो है वो लेट्स से डी के साथ कहीं जुड़ा हुआ हो, तो मैं इनडायरेक्टली कह पाऊंगा कि सी एंड डी आर मिक्सिंग एंड यू विल एक्सप्लोड योर सोल्यूशन, राइट? अगर मैं इस तरह से कह सकता हूं तो मैं इसका वाइस वर्सा भी लिख सकता हूं कि लाइक इफ एफ ऑफ बी हैज द रिप्रेजेंटेटिव ऑफ बी इज इक्वल्स टू रिप्रेजेंटेटिव ऑफ डी एंड सिमिलरली और एंड अब बी जो है वो डी बी और डी एक सोल्यूशन में, राइट? बट डी नीड सी टू गेट एक्सप्लोडेड, राइट? और बी में क्या मिक्स कर रहे हैं हम ए, तो सिमिलरली मैं वो चेक कर लूंगा कि इफ एफ ऑफ ए equals to f of c, and these two conditions should happen at the same time, right? Then only I can say that explosion will happen. Similarly, these two conditions should happen at the same time, right? Then only I can say that the explosion will happen. So if you are not clear with this point I just explained you, please reverse the video back to few minutes and understand it and then proceed on, right? आई एम जस्ट सेइंग दैट अगर सी और डी को मिलाने से एक्सप्लोजन हो रहा है, मैं हिंदी में एक बार बोल देता हूँ, सी और डी को मिलाने से एक्सप्लोजन हो रहा है, राइट? और हमें मिक्स करना है ए और बी को. अगर ए का रिप्रेजेंटेटिव और सी का रिप्रेजेंटेटिव सेम है, रिप्रेजेंटेटिव सेम होने का सिंपल सा यही मतलब है कि ए एंड सी आर फॉर्मिंग अ सेट, दैट इज इट. अगर मैं बोल रहा हूँ कि ए सी के साथ सेट फॉर्म कर रहा है, सी को चाहिए एक्सप्लोड होने के लिए डी चाहिए, राइट? और ए को चाहिए बी, चाहिए नहीं मतलब बी मैं मिक्स करना चाह रहा था ये में, तो मैं ये चेक कर लूंगा कि बी जो है वो डी से कहीं रिलेशन बनाता है कि नहीं, राइट? जो बी जो है अगर वो डी से कोई रिलेशन बना रहा है एंड बी एंड और हमें पता है कि ए और बी का रिलेशन हमें बनाना ही है, क्वेश्चन नहीं बोला है, राइट? सो ए बी सी डी विल बी इन वन सेट एंड एक्सप्लोजन विल हैपन ड्यू टू दिस सी इज इनडायरेक्टली कनेक्टेड टू डी, राइट? सिमिलरली मैं अगर आप ये समझिए तो हमने फिर वाइस वर्सा इसको हैंडल कर लिया है, दैट इज इट, राइट? लेट अस कोड नाउ, लेट अस एक्सट्रैक्ट दिस ए एंड बी, सी एंड डी. अब डेंजर के जो एरे हैं वो मल्टीपल एरेज दे रखे हैं, सी एंड डी, ई एन एफ till the size of m, right? So we need to check these two conditions with each and every danger array, and once we see that the explosion will happen for let's say c and d के लिए explode नहीं हुआ but e and f के लिए explode हो रहा है, then we will say that break from there. We will maintain a flag variable, a flag, or let's say boolean can mix. So initially we will assume that we can mix the solution, but once any of these conditions satisfy for any of these danger solutions, we will say that it is false, right? And break from that solution, right? Let us code it and you will get a clearer understanding. Also, please pause this video now and try to code it yourself, because खुद से कोड करना यार very important है ना. So if you have coded then well and good, क्योंकि अगर नहीं भी कर पाए तो कोई दिक्कत की बात नहीं है यार, जब अभी सीख जाएंगे तो नेक्स्ट क्वेश्चन अगर ये सेगमेंट डिसजॉइंट सेट, मैं पापा ने सेगमेंट्री क्यों बोल दे रहा हूँ बार बार, तो डिसजॉइंट सेट का आता है तो you will be able to easily tackle it, right? So let's form the A and B. So A and B was nothing but the individual solutions of my mix array. So let us iterate in my mix array and let us form int A is equals to find of the first entry, that is mix of I and 0, right? Similarly, I can say that int b is nothing but mix of I of 1, right? And I have to pass this thing into find function. ये इसका representative निकाल के दे देगा, and then we will be able to make sure that this representative उस subset set का representative हमें मिल जाएगा. Then we will compare with the danger array, right? तो हमें मिल चुका है यह representative a and b हमने निकाल लिया. हम एक boolean चीज maintain करेंगे, right? And we will assume that we can mix each and every solution, right? So we will say that can mix is equals to true, right? Now I have to iterate in my danger array, and I will see that if any of the danger entries is exploiting my condition or not. So I will say for j less than 0 to j less than m, j plus plus, right? अब मैं int c और int d वैसे ही सिमिलरली लिख देता हूँ डेंजर के लिए. तो मैंने लिख दिया यहाँ पे यार c और d. सिमिलरली मैं कंडीशंस कंपेयर कर लूंगा कि लेट्स से a इज इक्वल्स टू c and b इज इक्वल्स टू d, राइट? ये एक बार चेक कर लिया तो हम वाइस वर्सा भी चेक करना पड़ेगा, है ना? तो मैं क्या कर लूंगा, इफ a इक्वल्स टू d एंड ये नहीं समझ आ रहा था यार जहाँ मैंने ये पेंट पे मैंने लिखा था, आप एक बार फिर से वापस से बैक जाओ और इसको देखो, आप इसको समझो, बस आपको सब समझ में आ जाएगा. जो मैंने इंग्लिश में बोला आप इंग्लिश में सुनो, हिंदी में मैंने एक बार समझाया. हियर टू दैट थ्योरी एज वेल, यू विल एबल टू गेट इट, राइट? तो b is equals to c. So for that case, for in this case I will say that you cannot mix it, right? The explosion will happen. You have make a such set, uh, you have mixed the solutions and made a one such set where the danger solutions are also part of that set, and you will get the explosion. So can mix is equals to false. So once we code this solution, I will show you the dry run also, that how each and every line is behaving. So maybe after that you will be getting a very clear understanding, right? So after each and every iteration of mix array, right, I will now check if can mix, if it was true, right? Then what I need to do, that I have to form the subset of those two solutions which was mixed, that is a and b. Simultaneously I have to pass the yes string in my answer array. So I will say answer dot add yes, and else that you were not able to mix this solution, and you have to say in the answer array that is you cannot mix it, that is no, right? So let us compile and run this solution, and yes, so what will be, let us see that if there are no syntactical errors as well. So okay, so there are some syntactical errors, let me resolve that for you. Yes, so I have resolved the syntactical errors. पहला error ये था यार कि in the if I have not mentioned the parenthesis, right, the closing parenthesis. Second error was that I have not returned the answer. I have not changed anything in the union and find function. That was exactly correct. That was exactly written. I wrote in this paint pseudocode, right? Now what will be the time complexity of this code? You have run a for loop here of n, and then you have run it for m times. And for each and every for loop, you are just finding find operations, right? So let us see that what the find operation time complexity will be there. So let us go back to this code. So what you were doing, let us you have this tree 4, 2, and 0, and I said to find the representative of 4, which was actually 0, right? The root element of the virtual tree is always the representative of that subtree, right? Or set, you can say. So f of 4 was f of 4 said that my parent is 2, so I called for f of 2. F of 2 said that my parent is 0, I called for f of 0, and now f of 0 said that my parent is 0. So when the parent and the node you called for matches, then you reached your base condition. So what you can see, that I started from a node and I went back up ahead to the root node, right? So that means the worst time complexity will be that for a skewed tree, you have started from the leaf node and you are going back to the upright node, right? So it will be the height of the tree, right? In the worst case, right? And since you can see the chaining is happening there, right? So just to avoid this chaining itself, that is where the optimization of the union thing comes using a rank array. Rank is nothing but to maintain the height of the tree, right? So this chaining, so the skewed tree will never form if you do this optimization in your union thing, right? So considering that possibility, since the skewed tree will never form, that will be a balanced tree, then I can say that the height of the tree will be log n, right? So I can say that the time complexity of find function will be O of log n, right? Okay, so you have run a for loop for n times, then m times, and you are calling the find function inside it. So it will be n cross m into log n, right? Right. And the union and find function are all the parallel functions. Find will take log n. In the union itself, you are calling the find functions two times, so it will be log n again. So the overall time complexity will be n cross m into log n, right? Right. So, and if you see the constraints, if you see the constraint that n is nothing but 10 power 3, 10 power 3. So it will be 10 power 6 into log of 10 power 6. If I just write it for you, n cross m will be 10 power 3 into 10 power 3 into log of 10 power 3. If you solve this, it will be definitely less than 10 power 8, and that is why you will not get the TLE on this solution and your code will get submitted. TLE वाला approach क्या था यार? Brute force approach हमने discuss किया था कि whenever you make a subset, let's say 0, 1 to 2, and then you have the requirement of make to 2 to 3, then you have to traverse in the subset, in the previous subset you have to make a linear traversal, right? So for each and every entry, you have to see for the danger array, right? And for each and every danger array, you need to traverse in your subset, right? So the length of subset you make. So the length of subset with the maximum time complexity will be n again, so it will be n cross m cross n. That would be our brute force, right? एक linear traversal हमें करना होगा. So that is not, and if you have gone through that approach as well, it would not have been submitted. So this approach of disjoint set is much more efficient. And if I submit on this, click on this submit button, it will definitely get submit. So let us see and wait for the results. If 210 only 210 cases are there instead 220. सही मैथ से यार यहाँ पे ठीक है. So rest assured our solution gets submitted, but now also this code is not very optimized. Not optimized in the sense of disjoint set, because as I already told you, right, whenever you are making a subset, you will be keep on chaining the structure, right? 0 to 4. Let's say you have this condition of, let's say, to club 0 and 7, then you will say that 7 will come here. So that should not be the case, right? You should write the code in such a manner that the 7 should come here, right? 7 should come here. So let us see. ये वीडियो मैं अगर यहाँ खत्म कर दूँ 27 मिनट्स की, तो आ क्वेश्चन हमारा सॉल्व हो चुका है यार, राइट? But the disjoint set optimization is still remaining, right? So spare some 4 to 5 minutes more and you will see the optimization as well. So let me give you in the intuition behind the union by rank. तो हमारा question complete हो चुका है यार. We are just seeing the optimization that how the union by rank ensures avoids the chaining in this virtual tree representation, right? So let's say you have this case. You have this virtual tree as R1 and there are some nodes there and the last node is X. Similarly, there's another tree as the parent node, the representative as R1, the representative as R2, and has the below node as 1. Now, the rank, I will maintain a rank, right? Rank will be nothing but the rank of this representative R1 will represent the height of the tree, right? So the height you can see is 3, 1, 2, and 3. So it is 3. Rank of R2 will also be the height of this tree. So it is just 1, right? So if the condition came, if operation came of union of x to 1, right, then what would be done? What would be done is that instead, मैं यहाँ पे लिख दिया यार, this is the idea that make the parent whose rank is bigger. अगर मैं हिंदी में बोलूँ, जिसका रैंक बड़ा है उसको पेरेंट बना दो. What will happen if you see that the rank of this parent is bigger, R1, right? तो इसको हमें पेरेंट बनाना है according to this statement, right? So if we make this R1 as parent of this R2 and 1, then you can see that the height it again is equals to 3, right? If you'd have do the reverse of this thing, then the R2 would have come here, and the rank would have increased by 2 more numbers, right? So that should not be the case. So this is the reason, if you do this optimization using a rank array, which is nothing but maintain the heights of the virtual tree, you will avoid the chaining, right? And that is the reason that if you do the find operation, it does not take O of n time, because we are already ensuring using this optimization of this rank optimization that the virtual tree that you will make will be a balanced tree, right? And as I already told you, what the find do is you do, अगर आप find किसी node के लिए करते हो तो recursively it goes to the top of the node, because top of the node is itself the representative of that subtree, right? So that's why it takes the log n. तो ठीक है यार, इसका कोड हम कैसे कर सकते हैं? लेट मी राइट द कोड एज वेल एंड वी विल प्रोसीड. तो मैंने सूडो कोड लिख दिया यार. सेम है, हमें एक्स और वाई की यूनियन करना हो तो फर्स्ट यू हैव टू फाइंड द एक्स रिप्रेजेंटेटिव ऑफ एक्स यूजिंग द फाइंड फंक्शन, द वाई रिप्रेजेंटेटिव ऑफ वाई यूजिंग द फाइंड फंक्शन अगेन फॉर वाई, राइट? नाउ आई हैव टू चेक. लॉजिक ये था यार कि जिसका make the parent whose rank is bigger, right? So I will check with the two if statement. If the rank of x representative is less than the rank of y representative. So the rank किसका बड़ा हुआ यार, y rep का, right? So I will make the parent this, y rep will be the parent of x rep. It is as simple as that. This code is as simple as this, right? Similarly, what I can say, that the rank of y rep is greater, right? So y rep will be the parent of which, the x rep, right? This is as simple as this. In the else case, else will be nothing but the representative, the rank will be equal for both x rep and y rep. So in that case, you can increase the height of any representative. So let's say I'm deciding for increasing for x rep. So since you have made the y rep as the parent of x rep, then you have added one more node, right? Since the height were equal and you added one more node, then you have to increase the height as well. So right, so you will say that the rank of x rep plus plus, right? So you can also in the else case, just for the else case, you can use it vice versa. The x rep would have come here, the y rep should have gone there, and this y rep should x rep would have updated to y rep plus plus, right? So I hope you got the point, right? So let us implement this code in our editor, right? And there is one more optimization for the find function as well. So this is the find function which you wrote. There is one more optimization which is known as path compression, right? So let me give you the intuition on how the path compression works. So path compression, so what are you doing is, let me give you the intuition first of all, right? Then we will code it. Okay, so इसका use क्या था यार? Why the path compression comes in place? So let's say suppose you have this the tree where this tree 0, 1, 4, 6, 3, 7, 2, and 5. Yeah? You can see that this is the part of one set. And if I run this f of 3 on this, then what will happen? The same. If you use the earlier code, then you will start from 3 here, 3, right? Then you will call for 1, then you will call for 0, and then you will say, okay, the f of 0 is pointing to itself, so return 0, right? This thing you have to do. But अगर ये चीज हम कर ही रहे हैं, right? So the things which we are doing here is, if we are able to make, let's say for the node which you just found that your parent was, so why not assign this node, जिस node के लिए आपने अभी सर्च किया था, उस node को ही parent, डायरेक्ट parent बना दो अपने required जो parent आपको अभी मिला 0 का, right? So point the parent to the actual representative of this subtree, right? इसका advantage क्या होगा कि next time if you search, if you do the same operation for 3, or let's say for his descendant 6 and 7, then your process will be much faster than कि 6 जब यहाँ से traverse करके 3 पे जाता, 1 पे जाता, 0 पे जाता, यहाँ पे 6 just traverse करेगा 3 पे and then 0. You would have skipped one iteration, right? And if you call for 6 again, f of 6 again, then remove this 6 again, 6 here, and then point directly 6 to here, right? Then if the 6 अगर फिर 6 से आपने सर्च किया, it would be much even faster, right? So the whole point is कि जिस node के लिए आप search कर रहे हो, for the node you are searching the representative for, once you searched it, then directly assign it to its representative. So what should be the pseudocode that we can write is, the base case will remain same, that if x is equals to parent of x, that is, you have reached to a node where the parent and the node you called for the you did the recursive call is same, then you just have to return the x, right? Else what you were doing, that you were iterating for the parent of the number called itself, right? But now the extra thing is that you have to attach it, you have to make the parent of representative as well. So what I will say is, I will just write here that do this attachment as well, that the parent of x is this thing, right? I hope this will do the task, right? So if I on this tree, if I say that find 7, right? So that means that make 7 child of its representative, that is 0, right? So my tree will look like that 0 will be there, 1 will be there, 3 will be there, right? Now if I call this thing this on this tree, right, on this tree, so it will be 0, 1 and 4, and it will be 0, 2, and this was 5, then this was again 3, right? This is 6, and the 7 will be here, as I explained you for the 6. If I called f of 6 on this tree, then 6 will be deleted from here and it will be pointed to its original representative, right? So that's how the path compression works. It compresses the path, right? Path compress हो जाता है यार. It directly points to the representative there, so that the next time if the same operation come, then you will be able to do it in much lesser complexity. So already we are 34 minutes and still counting. तो मैं यार code पूरा लिखता हूँ, and then we will just submit the solution. Okay. So you can see that I have implemented the same optimized code here, right? The same code which I showed you in the pseudocode in the paint. The two things that I have changed, I have made this rank array here, and I have initialized the rank array as n+1, right? These are only the changes, the first change of the rank here, and then these two things. And I have commented out the rest of the find and union code, and you can see that compilation and run is running successfully, right? We will hit the submit button and you will see that our code gets submitted. Then we will discuss the time complexity, right? That what's the difference between the optimized time complexity as well as the previous time complexity. So let's wait for the results. Great. So it has been successfully submitted. So we discussed three approaches. The first, brute force approach, which involves the linear traversal, which would have been given you the TLE. The second approach is for the union and find. The union and find I just explained you here, right, in this paint section. The third was the optimization of union and find, right? Let us discuss the time complexity and then we will end this video. Okay, so the first was union by rank plus the path compression, right? This was the second the first optimization, and the first way was just the union by rank, just the union and find, right? The first was just union and find. So it was taking the log n, right? And union by rank plus path compression will take the time complexity of m alpha n, where we are assuming that there are n nodes and the m operations we are doing, right? So alpha of n is always less than equals to 4 if you do this compression, and this alpha of n is also known as inverse Ackermann function, Ackermann function, right? So there is a lot of mathematics involved here to just prove this alpha of n less than equals to 4 for each and every case. So I have just given you the enough evidences to support the theory that there is actual an optimization. You can search well more if you want, right? And for the union and find, it is n log m, supposing there is an m operations and there are n nodes in our structure, right? So that's it. Let's end this video here, right? And the last initiative is about the C++ code and the Java. So this is the Java code I explained you guys. This is the simple union and find. This is the optimized union, and this is the optimized find by the path compression, right? The same code in the C++ looks like this in the left hand side. C++ users will be able to understand it more rigorous and well. So they have vectors and all, everything. So I just scroll it for you guys so that you can also get help with the source code of C++. So that is it for today's video. Let us end this video and let us meet again in the tomorrow's streak of day 136, I guess. Till then, keep learning, keep going, and take care. Yeah. So this was a hard question, but don't be frustrated and demotivated. Just keep doing it and you will eventually get better in the long run, right? So let's end this video now. Bye bye.